Hugo. Hello, welcome. Welcome back to my channel. Welcome back to my classroom. And my calculator's my wand. We're not going to watch Mr. Popper's Penguins because today we're reviewing and testing. So if you're at home, in this same module, you see your test below. You'll want to print off this paper. We're going to review and test at the same time. Lego. Yeah. So, watch. Ready? I'm gonna tell you exactly what to do. The first review problem says, solve the equation, then select all of the solutions. Well, to solve the equation, we got to factor it first. And this is one of those ones where you have to split it and list all of the factors. Do you guys remember that? Yeah. If you're late, your paper's there on the edge of the table. So, we're gonna go 1 in 16. Does 2 work? Yes. 2 and what? 8. 3, 4, and? Okay, so here's all of our factors, and this subtraction sign here tells us we got to subtract them. So we get a negative 15, a negative 6, and a 0. Well, this is kind of close, but what do I got to do to make these match? The triangle. So our factors for this are x. So this becomes positive, negative, positive. So I'm getting x minus 2, x plus 8 equals 0. And we've looked at this a lot. We probably don't even need to set up the separate equations. What's the solution for x minus 2? It's plus 2. So x is 2. And what's the solution for x plus 8? Negative 8. So the solutions to this guy are x is 2 and x is negative 8. Oh, that needed to be an equals. Sorry. So now, if we go into Canvas and we open up our quiz, and by quiz I mean test, we go to our Canvas course. The test is right here. We open it up. The first question is similar to this now. You follow the same exact process. You factor that trinomial, and then you select the solutions. Okay, go. Do it now. I'll give you roughly a minute, and then we'll move on to number 2. Do you understand what's happening? Okay, I'd give it a try. Yeah, this is your test. So that's your review problem, that's your test problem. I would use this paper to work it out if you need to. Or your notebook. Got about 45 more seconds. We'll move on to number 2. If you're at home and you don't need this time, you should just fast forward to the next problem. About 30. 20. 10. Okay, so 1 and 2 are from page 46. And the one that we have next is one like this. It is a special binomial. So my notes are reminding me here that when I have a special binomial, I'm supposed to root the first term and root the second term. So on my paper here, I'm going to do that. And then the factors are an x plus and an x minus. But I remember, because we've done this a few times, that I might need to put an I on it. So I'm going to check this problem again. This one is a plus sign, which means the plus sign is the one where I have to put the I's. And I'm getting this from our notes because that's how we did it last time. So the root of 64 is 8. And then we put the I on. So what are our solutions to the equation? Negative 8i and positive 8i. So if we go to number 2, question 2 on our quiz, you see one that is almost exactly the same. So take approximately 45 seconds to do number 2. About 30. $20. 10. Okay, what are the real or imaginary solutions of this factored form? Well, this is one of our easier ones because we can skip this step where we have to factor it out and just go straight to the solving. The hint underneath says, determine the number of roots so you know how many roots you should select. So that's when we counted up how many x's we have. So we have 1 here, 1 here, and 2 here. So by the time we're done, we are going to have 4 solutions. We just discussed how to do these kind. If I have an x plus 3, what's my solution to that? Minus 3. The reason why is because you say x plus 3 equals 0, so you subtract 3 from both sides and you would get x as negative 3. So if we follow that same thinking, what is our solution for x minus 1? Positive 1. Now this guy's kind of tricking us because he's not factored, but he's exactly like this guy up here. He's a x squared plus a perfect square. So we root and root. What is the root of 4? 2i and negative 2i. Those are your solutions. The long way of doing that is x plus 2i, x minus 2i, then you set those equal to 0, and then you solve. That's where you get the negative 2i and the positive 2i. This is the long version. So now you guys go to number 3 in your exam, and you should see one similar to this. You select all of your solutions. See what's going on here? You're doing it. About 30. 20. 10. Okay, this next guy's a little bit longer because notice he's an x to the 4th and he's not factored. We solve him or factor him the way that we're used to though. So if we rewrite him down here just so that I have enough room to show work, I solve this by listing all of the factors of 4. And this one's kind of easy because there's not very many. There's 1 and 4, and then what? 2 and 2. This subtraction sign here means subtract the factors. We get a -3 and a 0, and it matches up perfectly, so we don't need to do any switching. Here's where the difference comes in, though. Because you have an x to the 4th here, how this factors out is x squared plus 1 times x squared minus 4. So it's similar to the very first problem, except for your term here is an x squared, because you started with an x to the 4th. And now you have 2 special binomials. These are those crazy ones that turn into 4 binomials. So this is our first set. We root the x. That gives us x plus and a minus. We root 1. What's the square root of 1? 1. So we get an x plus 1i and an x minus 1i. How did I know we had i's on this one? Because it's a plus right here. This one's the same. Root the first term. We have an x plus and an x minus. We root 4, which we did in the previous problem, and we know that's 2. No I, because this one is a subtract. So your 4 solutions are 1i, -1i, 2, and -2. So just like on all the other problems, if we now flip over to question 4, you get one that is similar. Give you a little bit longer than a minute on this one because these ones are way more complicated. Okay, let's go about a minute now. About 30. $20. 10. Okay. Number 5 on our review matches the work that we did on page 47. So it gives us the zeros and wants us to work backward and give the function in standard form, which requires us to multiply. So we have an x is 0, an x is 2, and an x is -5. What these started out as, well, the bottom two are the easiest. X is -5 started out as x plus 5. X is 2 started out as x minus 2. What did x equals 0 start out as? So these are from our notes. What does x equals 0 start out as? X. If you have an x is 0, he started out as an x. Now we put these together to multiply them. We get an x times an x minus 2 times an x plus 5. We split them and we do just the first multiplication. So all we got to do on this one is multiply in that x. So what is x times x? X squared. What is x times -2? -2x. And now, just because I like it, you can do whatever you want. I'm going to use box method to finish this up. So I'm going to take this x plus 5, put it down the side here, and find my solution that way. So x plus 5. X times x squared is x cubed. X times -2x is a -2x squared. 5 times x squared is 5x squared. And 5 times -2x is -10x. So I know my first and my last term are going to be an x cubed and a -10x. So it has to be either C or D. Now I combine these middle terms to make the final choice. So a +5 and a -2 goes to a +3. So it has to be C. Because this turned into x cubed plus 3x squared minus 10x. So we did that in our notebook, like I said, on page 47. This was 5. So now 5 in Canvas. Uh-oh, spaghetti-o. It should be similar. So your pencil should be moving if you're solving this out. Unless you're like super duper quick. go about a minute. About 30. $20. $10. $3. Okay, number 6 matches page 50 in your notebook. So they want you to identify which of these functions has one max and an end behavior of down and down. So I would personally just plug these in to Desmos until you find the one that has one maximum point and behavior down, down. I'll just come walk around on this one so that I know how much time we need. So you're plugging those into Desmos. You're identifying whatever your Canvas one says. I think it's one max, one min, and then what's your end behavior? Down, up, down. Oh, you can just copy and paste them right from Canva? Like we need about 30 more seconds. $20. $10. $5. Okay, number 7, first one on the back page is from page 49 in your notebooks. It wants us to identify the number of real, imaginary, and complex roots. So remember, complex just means the total number of roots. So when I'm done, I should have 1, 2, 3, 5 total roots. That's your very last box. And whatever you put in these top two need to add to this bottom one. Okay, well, my root for x is 0. Okay, x squared plus 36. This is one of those special binomials again. So this is going to be x plus 6i, x minus 6i, which means that your roots are x is negative 6i and 6i. Then your last one is another special binomial that factors to x plus 7, x minus 7. So these roots are negative 7 and 7. How many are real? Well, 1, 2, 3. How many are imaginary? 2. Your other option is you can graph it. So we could plug into Desmos that big thing. So I could plug in an x squared plus 36 x squared minus 49. And what I'm seeing is only 3 x-intercepts. So that would tell me that 3 of them are real and 2 of them are imaginary. So either way. So this is 7. So you have one that's very similar for number 7. Give you about 30 seconds. $20. 10. 5. Okay, so now we're on number 8, and we've actually already practiced number 8 today. The only thing that we didn't do was identify the roots from the graph. So your roots are going to be where it's passing through the x-axis. So I have them circled on my roller coaster. This means that the roots are negative 2. What's my next root? 1 and 1, 2. So if we're going to write that in factored form, well, x is negative 2 started out as x plus 2. X is 1 started out as x minus 1. X is 2 started out as x minus 2. That's it. That is factored form. So now this is both problem 8 and 9 in your quiz. So 8 just asks for the roots. Then 9, for the same graph, asks for the factored form of the function. Give you roughly a minute on that one, and then we'll finish up with the last problem. About 30. I don't think so, no. About 10. 5. Okay, our last question is just labeling all of the points that you see on this graph. So for all of these little bubbles, they want you to determine what it is. So for instance, this one right here is an x-intercept. We also know it as a root, a zero, a solution, a factor. We know it as all of those things. But what we first learned it as was an x-intercept. This guy, he's not our maximum, he's our relative max. Because our maximum is infinity. We haven't talked about 0, 1 in a long time, but what's 0, 1? Very good, thank you. These two here are both just x-intercepts. Which means that this very last one has to be your relative min. You guys feel okay about those vocab words? Yeah? Okay, so that is your last question in your Canvas test. So it wants you to, from a drop-down menu, identify the same set of points on a flatter roller coaster. You can submit and see how you did. If you don't like your score, you have one more attempt after this one. Then y'all need to get your quizzes done.